Hey guys, here is day 2 of your 7.4 notes. This is it. This is the last day of notes. Congrats, we have made it. Let's get through this. All right, so again, I'm just gonna go through some more identities with you. These ones are all about establishing an identity. So it's basically telling you to prove that the left side equals the right side, right? Try to get the left side to say the same thing as the right side, or try to get the right side to say the same thing as the left side. Try to simplify the more complicated side of the identity to become the simple side. So again, if you take the more complicated side, try to make it look like the simplified side or the simpler side. Use the simple side as a guide as to what you are trying to get the more complicated side to become. Okay? All right, so look here. Establish the identity. They want you to prove that cosecant theta times the tangent of angle theta is always equal to the secant of that angle. So technically, this is the more complicated side. So we're going to try to get this side to become the right side. We're going to turn this into secant theta. So right now, this is a pretty simple one. I think just rewriting things in terms of sines and cosines should get the job done. So cosecant theta is 1 over sine theta, and then you're multiplying it with tangent theta, which is sine theta divided by cosine theta. Your sine thetas will cancel out, and you'll be left with 1 over cosine theta. And guess who 1 over cosine theta is? It's secant theta, and that's exactly who we were trying to get this left side to become. So now that you have gotten the left side to say exactly the same thing as the right side, you are done. You have proven this identity. You have established it. You have established that the left side is saying the same thing as the right side. These are equivalent statements, okay? All right, look at the next one. Establish the identity that this equals the secant of angle theta. All right, so again, this is the more complicated side, so we're going to try and get this to simplify down and become secant theta. All right, so you have a couple options. Could you start writing things in terms of sines and cosines right away? Sure. I'm going to distribute first, and then I'll start rewriting. So I'm going to get sine theta times cotangent theta plus sine theta times tangent theta. And again, we're trying to get this to become just secant theta. So now I'm going to just bring in my sines and cosines. So this is really the sine of theta times cosine theta over sine theta is really what the cotangent of theta is. Plus, we have sine theta times tangent theta is just sine theta over cosine theta. So what are we left with? Well, these cancel. And now I'm left with cosine theta plus nothing canceled here. So sine theta times sine theta is sine squared theta. And it's over cosine theta. So now I have to add these together, which means I need a common denominator. What's the common denominator between 1 and cosine theta? Cosine theta. So I'm going to times top and bottom by cosine theta, and I'm going to get cosine squared theta. All right, and then that's going to be over cosine theta, and now I can add it with my sine squared theta over cosine theta. So you end up with cosine squared theta plus sine squared theta all over my common denominator of cosine theta. Well, guys, you should recognize this is an identity. Who's cosine squared theta plus sine squared theta equal to? It's 1. So this is 1 over cosine theta. And who's 1 over cosine theta? Secant theta. So I have just turned the left side of this problem into the same thing as the right side. So I have established this identity. This really does equal that because I can rewrite this as just secant theta. All right, and again, these are not the only ways to do these problems. Some of them have more than one way. I'm just trying to show you some of the most common techniques that your book is going to use, okay? All right, look at the next one. Sine squared negative theta plus cosine squared negative theta equals 1. Well, again, you have to understand what this means. This is sine negative theta squared. It's sine negative theta times itself twice. So it's really this. It's sine negative theta squared. That's what this really means. And then plus cosine negative theta squared equals 1. Well, now we can use an identity for this. So sine negative theta is equal to negative sine theta, right? We can break that negative out, plus squared, sorry, plus cosine negative theta, if you remember, was just cosine theta. And it's squared. And then again, we're trying to make this become 1. So I don't even need to put this part. We're just trying to show that it becomes 1. All right, well, look here. What is negative sine theta squared? Well, what's this negative 1 squared? It's positive, and then this will become sine theta, I should say, if like that, squared. Well, that's sine squared theta. That's how we write that. All right, and then plus, this is, and again, I guess I could have left that in parentheses, cosine theta squared is cosine squared theta. And what's sine squared theta plus cosine squared theta? It's 1. So now I have turned the left side of this